Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No. We've got a mixture here. Now, Amy's going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you can ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam, Praxis peeps, big shout out to you guys out there too. And especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hey, everybody. Welcome to Wednesday Night Math Night. I am excited to be here with you guys tonight. It is rainy over here in Florida. I am in Central Florida and it is rainy, hence the cozy attire tonight. It's been storming outside for an hour or so. So yeah, so that's that. I am Amy Sink. I am one of the math specialists here at the Learning Liaisons, and I just love what we get to do here, which is support you in your journey to pass these certification exams. These math exams are not easy. I love math, and some of these questions that you see on these exams are just so wordy, so confusing. In fact, I was tutoring my nephew this evening, and we were going through some SAT prep problems, and there was problems that were so wordy, and he literally looked at them and was like, I don't know how to do that. I don't know how to do that. And I said, but you do. And so we read through the problem, and it was some of the problems were very complex, but some of these problems were so simple, but the formatting and the language and all of that was just so cumbersome. And so that is our goal, is to help you get through some of those cumbersome problems because you have that content knowledge. So that's our goal. We have a lot of goals, but that's one of them. Like I said, I'm Amy Sink. I am from Central Florida. I am an assistant principal. And fun fact, I just got hired this year at the school that I went to in middle school and high school, which is super cool. It's like a nostalgic moment for me to be able to just walk around this campus and empower and inspire these kids that are stepping foot on the same campus that I was at. So it's super fun. And I am excited to hear about your journey and your passions and more about you. So I wish we were sitting in a circle today in my living room, but we're not. So let me know in the comment box, where are you from? What test are you prepping for? And what is your dream job? Like realistic dream job, like not like you want to be an astronaut and that's never, ever, ever going to happen. I would have said my dream job would have been either to go back to the school that I'm at as eventually a principal, but as a leader, so an assistant principal. I am literally living my dream right now. Or to be a math teacher and a competitive dance coach at a high school. Like those would have been my top 2 dream jobs. So what is your dream job? So where are you from? What test are you prepping for? And what is your dream job? Is it to teach kindergartners math all day? Is it to teach only pre-calculus? Is it to be a soccer coach? Like, what is that thing for you that you're like, if only I could do that, I would be living. So without further ado, we are going to go over about 8 to 10 problems. Usually I don't get to all 10 because I just go on rabbit trails to make sure everybody is getting something out of every problem. And then on top of that, I always have a next week section. So last week there was a lot of like K through 6 people in the room. And so there was a lot of requests for specific K to 6 stuff. And so the back half of today is K6 heavy, y'all. It is heavy K6 in the back half, but the front half is for my, upper level math people. So let me know as we're working in the comments, what do you want to see me go over in the upcoming weeks? It really helps if you give me more specifics. And so it really helps if you're like, I'm struggling with geometry. I'm struggling with, whatever it is. Let me know. That really helps me kind of craft these problems. And it helps me tailor these sessions to you. So let me know what you want. And don't hesitate to ask questions. I love when you interact, and so don't hesitate to ask questions. Octavia, you are in Florida as well, prepping for the GK math. This is your 5th time. Listen, you are not the only one. You are not the only one to take it more than once. You are not the only one to take it more than 5 times. In fact, you're not the only one. Like, there are people who take it 8, 9, 10 times. So you're not the only one. It is discouraging, but a lot of it's up here. It is discouraging, but a lot of it is up there. So we got to get over that hump, and you can do it. Lydia, Texas K6, EC6 math, pre-K teacher, and then a child psychologist. I love that. And Marie, FTCE K6. I'm telling you, there's so many of you that are prepping for K6, pre-K through 6, GK. There are so many of you. Also, did you guys watch the Little League World Series? We were keeping up with it because Lake Mary is literally like a stone's throw from us. And so the kids, I actually know some of the kids that were on that team. They were at my old elementary school. So it was so fun to watch. And we were actually at dinner at P.F. Chang's one of the evenings that they were playing. It was before the actual World Series. And it was just so fun to watch these kids play. So did you guys watch the World Series? That's another side question for you, because that was really fun to watch. And it was so cool to see the kids and the coaches console the other team because they had worked so hard to get there. So that was really cool to see too. All right, let's get started with math, y'all. Let's get started with some math problems. In the upcoming weeks, GK math, geometry, and comp 3. You got it. Geometry and comp 3 specifically for GK. I will absolutely make sure I include some of that stuff in there. All right, here we go. Triangles A, B, C, and X, Y, Z are congruent, and angles B and Y are right angles. The measure of angle X is 27 degrees. What is the measure of angle C? The measure of angle X is 27. What is the measure of angle C? All right, so this is for everybody, especially for my GK and up people. The first thing I'm always going to do when I have a problem like this is I'm going to draw whatever they're telling me to draw. So if I'm doing a geometry problem, I am going to draw a picture. So I have two triangles, ABC and XYZ, and I heard something about there being right angles. So I'm going to draw two right angles. Hope, it is good to see you, my friend. So here's a right triangle, and here's another right triangle. And it said they were congruent. So I'm going to draw them to be as exact as possible. And I have ABC and XYZ, but I'm A, B, C, X, Y, Z, and angles B and Y are the right angles. B and Y. Well, I labeled my triangles wrong because this is my right angle and it needs to be B and Y here. So I am going to go ahead and erase this. And I did that on purpose so you could see how I would solve that problem. So, and my iPad just, if you're new, the iPad, disconnects every once in a while. So we just reconnect it and keep going. So when we're talking about triangles, A, B, C, X, Y, Z, the letters that are in the same position match. So like A and X go together and so on. So you want to make sure, like, if it doesn't say that A and X are like matching with each other, you know that because the order in which they name them, they match. So A and X match, B and Y match, C and Z match. So I'm going to start up here, A, B, C, because B is the right angle, X, Y, Z. And then it says the measure of angle X is 27. Well, if X is 27, then what else do we know? If X is 27, what else do we know? We know that A is 27. So I can go ahead and label this a 27 too. So A is 27, X is 27. And the question is asking, what is the measure of angle C? So I'm looking for this one. And because I was able to translate this 27 to this 27, now I can just use my understanding that all triangles, angles have a sum of 180 degrees. Now, that's a whole lot of math language for one sentence. All triangles, angles have a sum of 180 degrees. All that means is that when you add all the angles up, sum, you get 180 degrees. So I know that I'm going to do 27, and I'm going to use a different color. 27 plus 90, because a right angle equals how much? 90 degrees plus something has to equal 180 degrees. So I'm going to use my 4-function calculator, and I'm going to do 90 plus 27. And that equals 117. So 27 plus 90 equals 117. And then I can just do 180 minus 117 to figure out that missing angle. So 180 minus 117 is going to give us 63. Questions about that problem? All right, let's move on to problem number 2. Square M has side lengths that are 114 times the side lengths of square N. The area of square M is K times the area of square N. What is the value of K? What is the value of K? All right. So again, here we are dealing with geometry. And so we need to draw a picture. So I'm going to draw square M. I'm going to draw square N. And then I'm going to keep moving forward. So square M and square n. And these might not be drawn to size, and that's okay. Actually, I know they're not. So this is actually going to be square m, and this is going to be square n, because when we read it, it says square m has side lengths that are 114 times the side lengths of square n, which means it's that much more. So square m is going to be bigger. So if you understand proportion and you understand scale factoring, then this question is pretty easy for you. And if you don't understand scale factoring, then this question might seem a little bit difficult for you. But let me show you a little trick that I like to do sometimes when solving problems like this. Hey, Celeste, remind me what Math 118 is. Is that like K6? Is that middle school? Is that high school? Is that more of like a core? What is Math 118 specifically testing for? Let me know and I'll be able to answer that question better. So if you don't, K3, this problem is not, but stick around because the back problems I've built specifically for K3. So if you stick around, you'll be able to see some really good problems for K3. So if you're like, I really don't know where to start, here's what I know. I know that we're talking about side lengths. And if we're doing scale factoring, I know that no matter what numbers these are, the proportions are going to be the same. So I'm going to just come up with random numbers for n. I'm going to say that this is 4, which means this is 4 because a square has all the same side lengths. So Celeste, that was a great question. I'm glad you asked, because even though this problem is not for K3, what I always like to do is try to at least insert little nuggets for everybody. So in the K3 test, you need to understand that a square is a quadrilateral and a square has all 4 of the same size sides. And so even though this problem isn't for you, little nuggets like that I insert are very important. So this square has side lengths of 4. So the area of this square is 4 times 4, which is 16. If the side length is 4 for square n, and square m has side lengths that are 114 times the side lengths of square n, then to find the side lengths of square m, I can do 4 times 114, and I can do 4 times 114 and get my side lengths. So we're going to go ahead and do that right now. 4 times 114, 4 times 114, 456. So 456 and 456. Now I can come up with the area for that square. So 456 times 456 equals 207,936. Now, we know that the side lengths are 114 times the side lengths of n, but to figure out the scale factoring of how many times more is this area than this area, I can do 207,936 divided by 16 to figure out that missing value, to figure out that K value. And the K is the K, the M, and the N are going to be what throws everybody off in this problem. But really, it's not that big of a deal. So that's going to equal 12,996. Now, here's your bonus lesson. Your bonus lesson, and I'm going to duplicate this page and erase all my notes here because I want you to pay attention to this. Because while that is a way to solve this problem, and coming up with not imaginary numbers like in the high school world, but coming up with pretend numbers for problems like this really does help. And it's one of the ways I still solve problems to this day. While all of that is true, if we're looking at linear scale factor, is 114. Then area scale factor is going to be 114 squared. And volume scale factor is going to be 114 cubed. If you have your linear scale factor, which is just the distance from point A to point B, so it's how long the sides are, and I'm trying to figure out how many times bigger the areas are, I can square the linear scale factor. I'm not going to multiply it by 2. I can square it because area is units squared. And if I'm looking for my volume scale factor, I can take the linear scale factor and multiply it times itself 3 times. I almost said multiply it by 3, but that's not the case. I'm not going to multiply it by 3. I'm going to cube it because volume is units cubed. So if this is my linear scale factor and I just do 114 squared, I'm going to get 12,996. So for my people who understand that, that's a super easy, quick, cheat way to solve this problem. For my people who don't understand that, and quite frankly, between you and me, the way I solved this problem the first time I saw it, which was this, make up numbers, multiply it times 114, and get the answer to your problem. There are multiple ways to get to an answer to a problem, which is the best part about math. We don't have to take the same path to get to the same place. Let's look at problem number 3. The function f of x passes through the points 0, 3 and 4, 27. The function f of x has an x-intercept at a, 0 and a y-intercept at 0, b. What is the value of a minus b? What is the value of a minus b? All right. I modeled this problem after a problem I was doing with my nephew today because he looked at this problem and was like, I don't know how to do that. I was like, what do you mean you don't know how to do that? Like, this is linear functions. You know how to do linear functions. What do you mean you don't know how to do that? He was like, well, what does this notation mean? And what is an a, 0 and a 0, b? Y'all, let me break this down for you and you're going to be like, oh. So the function f of x and f parentheses, x parentheses, for some reason when we see a bunch of this, it's just a whole bunch of symbols and people get confused by it. Not confusing, it just means that there's a function and it's y equals and it just doesn't, it passes the vertical line test, right? And it passes through these points. So I could graph it, but I really don't feel like graphing something that goes all the way up to 27. And the function has an x-intercept, a, 0, and a y-intercept, 0, b. Y'all, you know what intercepts are. You know that an x-intercept crosses the x-axis and a y-intercept crosses the y-axis, and an x-intercept is always going to have a 0 in the y place because I'm going over, up 0. And the y-intercept is always going to have a 0 for the x because I'm going over, or no, I'm going over nothing, and then I'm going up, or down. So all of this is just saying, hey, yo, it has an x and y intercept, which you already knew because most lines, unless they are horizontal or vertical, have both an x-intercept and a y-intercept. You knew that. So all that said, there's a whole bunch of lingo in here that's just saying, if they took all of that out and they said, hey, we have a line and it goes through these points. What is the value of the x-intercept minus the y-intercept? That is all they are asking in a bunch of words. That's all they're asking. All they are asking is, what is the value of the x-intercept minus the y-intercept. That's it. Well, now we can just solve for that. So I am not going to graph it. You could graph it if you want. I don't find graphing to be the most efficient way, especially if I'm having to sit here and graph all the way up to 27. I am bound to make a mistake. So I am going to graph this. No, I'm not going to graph it. Sorry, I am not going to graph it. I am going to create an equation for this so that I can find my x-intercept. So I have y equals mx plus b. This is slope-intercept form. It's my favorite form because it gives you your y-intercept and it gives you your slope. Now, if you're like, but we don't know what the y-intercept is or the x-intercept is. If that's the case, then you can use y minus y1 equals m times x minus x1. And this is point slope form, where m is your slope and the x1, y1 is your point. And so if you don't have your intercept, then it's easy to put it into this form and then solve for the y. But how do I find slope if I have 2 points? Slope is, and I need to switch colors so we can delineate. Slope is rise over run, which is the same as subtract your y's over subtract your x's. Now, for some of you, you remember it being y2 minus y1 and x2 minus. The 2's and the 1's don't matter. Let's not jam our head with extra information. The 2's and the 1's don't matter. What matters is that you use the same y on the top as you do the bottom. So like if you're doing y minus y, just make sure that you do the same x on the bottom first. So I'm going to do 27 minus 3 because this is for everybody, this little nugget. Your x comes first and then your y, just like in the alphabet. A, B, C, D, E, F, G, H, I, J, K, L, M, N, P, Q, R, S, T, U, V, W, X, Y, and Z. X comes first. So I know this is my y and I know the 3 is my y. Over 4 minus 0. 27 minus 3. 24. Over 4 minus 0 is 4. So that all equals 6. So my slope is 6. So I have y equals mx plus b. What is my b? What is my y-intercept? Well, they gave it to us. It's part of the problem. You'll notice right here, tucked in the middle, 0, 3 matches 0, b, which is your y-intercept. 3 is my y-intercept. So I can plug that in right here. I also know that if I'm trying to find a minus b, I already have the b, which is 3. A minus b, which is 3. And I just realized the correct answer is not going to be here because I made a typo and I did not include the negatives. So we're just going to do this. We're just going to erase it. There we go. Okay, so a minus b, b is 3. How do I find my x-intercept? What do I know about all x-intercepts? Every single one of them, no matter what. Every single one of them, no matter what. What do I know? I know that my x-intercept is going to have a 0 for the y. So if I plug in 0 for the y, I can solve for the x. Now, if you're not familiar with how to solve a basic two-step equation, pay attention. I'm trying to get x by itself. So I'm going to subtract 3 from both sides. Negative 3 equals 6x. How do I get x by itself now? This is for everybody, even though this problem wasn't. Everybody needs to understand how to find at least everybody K6 and up. Maybe not my K3 people. How do I solve a basic equation? How do I get x by itself? Undo what's being done. So right now there's multiplication happening. So I'm going to divide. 6 divided by 6 is 1. So x equals -1/2. So -1/2 minus 3 is -3.5. And that's my answer. Questions? All right, let's keep going. Y'all, I am excited for these. These are going to be fun. Are you ready? Okay. All cars have at least 2 doors. A Ford Focus is a car. So the Ford Focus has at least 2 doors. All cars have at least 2 doors. A Ford Focus is a car. So the Ford Focus has at least 2 doors. True or false? True or false? Or not enough information to determine. So because this did not say some, because this said all cars have at least 2 doors, and a Ford Focus is a car, that means the Ford Focus has at least 2 doors, which is true. Now, this example seems super easy, but this becomes critical when we're looking at math statements, and we have to not put in our prior understanding or our bias or whatever you want to call it into the math language. You don't want to put that into the problem, because especially in geometry, they love to draw figures that are not to scale, and they love to ask questions like, is a square a rhombus? And you have to use this deductive reasoning, inductive reasoning, contrasting, conversing statements, inverse statements, contrapositives, without even realizing you're using all of that to come to a conclusion. So let's go ahead and look at another one. All crows are black. All blackbirds are loud. Crows are birds. What is this an example of? Inductive reasoning, deductive reasoning, a contrapositive statement, or a positive statement. Inductive reasoning, deductive reasoning, contrapositive, or a positive statement. So this one is interesting because we're not really doing like an A plus B equals C in this scenario. So all crows are black. So we know all crows are black. And all black birds are loud. Crows are birds. This is an interesting statement because typically, if you were looking at an example like this, it would say all crows are black, all blackbirds are loud, crows are loud. But it didn't say crows are loud. It said crows are birds. So this is not a contrapositive or positive statement, because a contrapositive statement is like if P then Q, if not Q then not P kind of stuff. And they're not doing that. So we have to decide, is this inductive reasoning or is this deductive reasoning? So inductive reasoning and deductive reasoning are opposites of each other. So deductive reasoning goes from general to specific, and inductive reasoning goes from specific to general. So we can say that this is inductive reasoning because we're going from specifics about crows and about birds, and we're making a generalization about crows by using the specifics they gave us. So they said crows are black, They said blackbirds are loud. And so because blackbirds are loud, we're making this generalization. We're going from specific details to a more general view that crows are birds. Interesting stuff, huh? Now, these 3 types of problems that we're going over right now are not on everybody's test. These 3 specific types of problems are not on everybody's test. You would have to look to see if you have converse statements, inverse statements, contrapositive statements, inductive reasoning, and deductive reasoning. If you have any of that, then all 3 of these are for you. If you don't have any of that, then you really probably don't need to worry about the specifics, but what you would need to worry about is how it applies to mathematics and geometry. All right, let's read the last one. If it is cloudy, then it is hot outside. If it is cloudy, then it is hot outside. Which of the following would be the contrapositive statement to the statement above? Which of the following would be the contrapositive statement? If it is not cloudy, then it is not hot outside. If it is not hot outside, then it is not cloudy. If it is hot outside, then it is cloudy outside. And if it is not hot, then it is not cloudy. Whoo! That's a whole lot of words in one problem. All right, so when we're doing problems like this and we're trying to figure out if it's contrapositive, converse, inverse, whatever, we're starting with a if P, then Q. So this part is P. And I'm going to erase this and make it a different color so that you can visually see what we're working with. Then Q. And then this part is Q. So if it's cloudy, then it is hot outside. I purposefully picked an example that does not make sense at all. Usually, if it's sunny outside, it might be hot outside, you know, if it's in Florida and it's in the middle of the summer. But just because it's sunny doesn't mean that it's hot outside. And if it is cloudy, then it's probably not hot outside unless you're in Florida. But all that to say, this statement was important because I wanted to use a statement that didn't make sense, because that's where our brain needs to go, is when it doesn't make sense. So if it's cloudy, then it's hot outside. If it is not cloudy, so this is not Q, because remember, or not P, sorry. P is cloudy. So not P, then it is not hot outside, not Q. If it is not hot is Q, so this is not Q, then it is not cloudy, not P. If it is hot outside, so if it is Q, then it is cloudy outside, then it is P. And if it is not hot, not Q, then it is not cloudy outside. Oops, we have the same answer twice. My fault, not P. So B and D are the exact same. So we're just going to cross off D because it's the exact same thing as B. So which one of these is contrapositive? Here's a little chart to help you remember. Converse, inverse, contrapositive. So converse is if Q, then P. Just flipped. Inverse is not P, then Q. Then not Q, sorry. Not P, not Q. Contrapositive is not Q, not P. So I think of inverse as the opposite. So not P, not Q. I'm just adding a not to it. And converse is just the flip of it. But contrapositive, because it's so long of a word, is like the opposite and the flip. Like it requires the most steps. We're going to flip the P and the Q, and we're going to knot them both. So not P, not Q is inverse. This is inverse. Not Q, not P is contrapositive. And QP is converse. So our answer is going to be B in this case. All right, Octavia, you said more of problem 3. Problem 3 was, like the more complex y-intercept, x-intercept linear equations. Okay, so I'll just put more of number 3, and I'll remember what that means. I love that you're giving me stuff that you're struggling with, because that means I can cater it to you next week. Everybody else, let me know what you need help with, because I can cater it to you next week. All right, or in the upcoming weeks, let's be honest. All right, my K through 3, my K through 6 people, drum roll. These problems are for you. Now, my high school and middle school people, don't run away so fast, because what they're doing is foundational for what you're doing. And I do have some student error problems that I'm going to talk about for everybody. So don't run away just yet. Problem number 7. Students in a kindergarten class are placing colored cards in the following order: red, yellow, red, yellow. What is the overall importance of this type of activity? What is the overall importance of this type of activity? A, the students are learning patterning for an art class. B, the students are practicing patterns which will help them build a foundation for algebraic thinking. C, the students are playing a sorting game to see which color has more. Or D, the students are practicing counting sets of 2. All right. So we're in a kindergarten class. Let's keep that in mind, because that's going to give us perspective on the age of the student that we're working with. And they're doing patterning, red, yellow, red, yellow. What is the overall importance of this type of activity? They are not asking you for what's the importance of this activity today. They are not asking you what is the goal of this activity by the end of the week or even by the end of the year. They're asking for the overall importance. Now, if we are talking about math class and they're doing a red, yellow, which we know we're talking about math class because we're taking a math test right now, they are not learning patterning for art class. Patterning is actually super critical in math class, and often the patterning that is done in art helps kids develop that understanding, and the patterning we do in math helps in art too. But a kid doing red, yellow, red, yellow is not building skills for art class. The students are practicing patterns. Yes, they are, which will help them build a foundation for algebraic thinking. If you don't understand what algebraic thinking is, then you're not going to understand what the purpose of this response or this answer choice is, right? C, the students are playing a sorting game to see which color has more. Are they sorting, or are they putting cards in a specific order? This is where it gets sticky. They are not sorting the cards. They are putting them in a specific order. Or D, they are practicing counting sets of 2. They're not doing that either. So if you don't even know what algebraic thinking is, this is still the best answer, because they're literally not doing A, C, or D. Now, what is patterning? Patterning is red, yellow, red, yellow. Why is patterning important? Because algebraic thinking is literally the ability to recognize and analyze mathematical patterns and make generalizations based on that. My upper school mathematics people, what kind of patterns do you deal with and do you see in the upper level mathematics? See how I'm taking this early childhood problem and tying you guys in? Well, what is this? A pattern. That's a pattern. That's a linear equation that has a slope of -2. So this has a slope of -2, and the ability to see that pattern and extend that pattern and then make generalizations on the fact that the line is going down. All of that stems from this. If a kid can't see this pattern, they're certainly not going to be able to see this pattern. That's why patterns are important. And those patterns continue into geometry, algebra 2, pre-calc, and calculus. All right, let's look at a second grade classroom now. In a second grade classroom, students are learning about addition and subtraction. Which of the following strategies would best help students who are struggling to understand the concept of subtraction as taking away? A, using a number line to count backwards from a given number. B, drawing a picture of objects and crossing out some of them to show subtraction. C, practicing addition problems with numbers up to 20. Or D, memorizing subtraction facts through flashcards. If you want a hint, you usually want to choose the answer that talks about manipulatives, base 10 blocks, something like that. That's a hint, especially if you're taking a K6 exam and it's talking about a strategy. Now, if the strategy is later in the unit, it's more developed, then that's not going to be the right choice. But so many of these types of problems, they're looking for you to say, I'm going to use manipulatives. I'm going to use hands-on strategies, because the development of mathematical thinking goes concrete, pictorial, abstract. The development of math thinking goes concrete, pictorial, abstract. And so if we're going in that order, then if we are struggling to conceptualize addition and subtraction as taking, or subtraction as taking away, I want to go back to that concrete model, and I don't want to do an abstract like 18 minus 7. What is it? It's 11, because 18 minus 7 is 11. That's not what we want to do. We want to go back to that concrete, pictorial, abstract model so that students understand. But when we look at this development, when we look at what answer choices we don't have a bring out the red and yellow counters option. And so because of that, we have to figure out a different option. If I'm trying to show subtraction as taking away, then hi, friends. So my computer, I don't know what just happened. It just like disconnected, and here we are. We're back. So if we're looking for something to help students developmentally move forward in their thinking and they're already struggling, we want to look for either a picture or like a number, or like a concrete model. But in this case, we didn't have a picture as an option. So that's why we're looking for some sort of, in this example, we didn't have base 10 blocks, or we didn't have manipulatives as an option. And so that's why we want to look for a picture option instead. The number line in this case, and now it's not connecting, so we're just going to do this because we're almost done anyways. Using a number line is not going to be the best strategy because a number line is not going to show subtraction as taking away. A number line is not going to show subtraction as taking away. A number line is going to represent subtraction as a fluid movement to the left on a number line, but it's not going to represent that taking away. Drawing a picture of objects and then crossing them off truly models that I'm taking stuff away. If I'm drawing a picture and then I'm crossing stuff off, I am taking them away. Practicing addition problems with numbers to 20. Well, this is a critical strategy for the relationship of subtraction, but this strategy would be used if we're looking for the relationship between addition and subtraction, not subtraction is taking away. And then memorizing subtraction facts through flashcards, that is definitely not going to be your best strategy almost ever. On these tests, remember, we're doing it based on what the test thinks. The test does not think memorizing something is the best strategy, and it really isn't. But that could be an argument for another day because some people really think memorizing is important. Conceptual understanding is important, and if the student has conceptual understanding, they are naturally going to get to the memorization piece most of the time. But memorizing is not the best strategy, especially for a struggling learner who is trying to understand why subtraction is taking away. Does that make sense? All right. Next week, we are going to start with 2 problems that kind of follow that same thing. We're going to do some error analysis in K through 3 and pre-K through 6. And so next week, we're going to start with that. I also have my next week list running here. And so if you want to see anything else from me in the upcoming weeks, let me know in the comment box. I am going to sign it back over to Dr. A, but I look forward to seeing you next week. Have a fantastic Labor Day weekend and have a great long weekend, and I will see you next week. Bye, friends.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35, that will take off 35% off any of our prep courses on our website at the Learning Liaisons. It doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today. And hopefully we'll see you next week too. Talk to you soon.